Hello, in this video I'll try to show you how to use such tool as EEG and PSG trends in neuronspectrum.net software for analysis long-term EEG and PSG examinations. First of all, let's speak about what we need trends for. For example, on this slide you can see native EEG traces. It is only one screen. In long-term EEG examination we can have hundreds of such screens. You can see here few sharp waves which were selected automatically by the software. It is quite difficult task to find such waves with only naked eye. And as I told before, we have hundreds of such screens with a lot of data, and it is very long time to review and analyze all this data without any other tools for analysis. So, what is it trend? Trend is a result of calculation of some parameters presented in a time scale. With help of trends, we can see all examination in only one computer screen, and result of calculation will be presented in very easy way to understand, review and analyze. We can compare two different trends and make conclusions about dynamic of different parameters, or make a conclusion without need for long-term reviewing and analyzing of native EEG traces. Here are some examples of different kind trends. For example, here is persist window of trends, one of the most popular EEG software in United States. Here we can see Amplitude integrated EEG, density spectral array, rhythm presented trends and others. Here is Encevis Neurotrend from Austrian Institute of Technology. Here also we can see different type of trends in 3-hour sweep speed. Nicolet trends also presented different calculated parameters such as rhythms, indexes, amplitude integrated EEG and others. And here is neuronspectrum.net trends. We also can calculate all these parameters and represent it on the screen of the computer. And now let's have a look on EEG trends window more carefully. On this screenshot you can see native EEG traces on the bottom part of the window and trends window on the top part of the window. Here we can see two columns of trends windows. In the main part we can see trends graphs. On the top we can see toolbar. With help of this button we can move trends, make different sweep speed, time scale and so on. Each trend have scale on the left side. Also trend have timeline on the bottom and information panel on the right side. On information panel we can see results of calculation of the trend on the current time. Also, some trends have controls for setup visibility parameters. For example, hemisphere mode or changing levels or something else. On the trends settings window, we can set up visibility of trends. We can choose what trends we want to calculate, what trends we want to see on the screen or we want to hide from the screen. Also, for each trend we can select what duration we should use for calculation of this trend. We can use all EEG durations or we can choose only few of them. Also, some trends has option to fill area under graphic. It's useful when you use trends on the window, but if you want to print them on the printer, it is better to not full fill area under graph. Also, here you can select how many columns of trends you want to see on the screen and minimum trends height. On this slide, you can see a list of all available EEG trends in neuronspectrum.net software. And now, let's have a look more detailed for each this trend. So, our first trend is density spectral array, or so-called continuous spectral array. This trend is compressed results of spectral analysis. It shows amplitude of spectral graphs during the time. On the axis, displayed the frequency of the spectrum and the range of rhythm: delta, theta, alpha, beta low frequency and beta high frequency. The amplitude of the spectrum power is displayed on this two-dimensional field as a point of defining color, which is given by the color scale from red to blue through green. Blue color means low amplitude of spectral graph, red color means high frequency of spectral graph. The information panel shows the frequency composition of the signal at the current time. According to this trend, it's easy to track at which moments of time what frequencies dominated in the signal. For example, here we can additionally see dominant frequency on the trend with this white line. And we also can recognize that during first hour of our recording, we had dominating frequency in alpha range. After that, it's dramatically moved to slow waves in theta and even delta range. Dominant frequency shows the maximum peak of spectral graph. In left side of this trend, we had like this spectral graph with maximum frequency at alpha range, and on the right side we have like this spectral graph with maximum in delta range. Also, we can see on the density spectral array so-called spectral age with white line. Spectral age is a frequency which divides spectral graph on two parts, with 95% of total power spectrum on the left side and only 5% from total power spectrum from the right side. This part of spectrum is not significant for analysis. So using spectral age, we can clearly see where is our significant frequency is located. And again, during first hour, we can see that not significant frequency is located above the high beta diapason, and on the right side we can see that spectral age is located even in alpha range. Our next trends are rhythm indexes of delta, theta, alpha and beta rhythms. These trends are showing what rhythm is located in what time. For example, on this screen we can see that alpha rhythm was dominating during first hour of our recording. Then delta rhythm becoming more available. Theta and beta rhythms are on the same level during all the recording. On the information panel we can see current value of each rhythm index. The sum of these digits are 100. Other trends shows us rhythm indexes ratio. For example, here we can see ratio between alpha and delta indexes, and we can conclude that during first hour of our recording, alpha rhythm dominated under delta about 5 times, but then delta rhythm becoming more amplitude than alpha. All information about rhythm indexes we can see using only one trend, rhythm indexes ratio. Using this trend, we can see all rhythms indexes using specified colors: brown for delta, red for theta, green for alpha, and blue for beta. And here we also can see that during first hour of our recording, alpha rhythm was dominating on our recording, and after that delta rhythm become more amplitude. For example, here we can see how spectral graphs can look like during these two different parts of our recording. Here we can see dominating alpha frequency, and here delta becoming more amplitude. Also, we can calculate this trend for different durations. For example, for left hemisphere on the top and for right hemisphere on the bottom. And we also can compare signals frequency between these two trends. And we can see that on the right side we have alpha rhythm dominating, but on the left side we cannot see such image. We can see that delta and theta rhythms are also dominated here, and this means that EEG activity is more slowly on the left side for this patient. Our next quite useful trend is average EEG amplitude, or so-called envelope. This trend shows the average amplitude of EEG waves calculated by specified derivations. By default, all visible durations of the montage. The information panel shows the current average amplitude of all EEG waves at the moment. With the help of control, we can change the scale of this trend as well as set the level of the amplitude, which will be highlighted in red color. Using hemisphere asymmetry mode, we can highlight with blue and red in which areas average amplitude are more in left or in right hemisphere. Very close to average amplitude, this trend, called maximum EEG amplitude. The difference is that this trend shows us the maximum EEG amplitude calculated by specified durations. Also, this trend has the same controls: hemisphere asymmetry mode, information panel, and red color highlighting. Next trend is number of spikes and sharp waves. When software calculate and search all spikes and sharp waves, with help of this trend we can easily see in what time of our recording we have a lot of spikes and sharp waves. And we also can very fast navigate between these areas of our examination. Next trend is total power spectrum trend. This trend shows us total power spectrum during the time. Total power is calculated as an area under spectral graph from the 0.5 up to 35 Hz. This trend shows us areas during our examination where the EEG total power spectrum is higher and where is lower. This trend is also well correlated with average amplitude EEG trend. You can see here on the top is EEG average amplitude trend, and on the bottom total power spectrum trend. We can clearly see that these two trends are quite well correlated because they show quite the same information. where the EEG amplitude was bigger and where it was smaller. Next, quite important trend is amplitude EEG trend, or amplitude integrated EEG. Firstly, this trend was calculated in 1971. Native EEG traces are filtered in the range of 2 up to 15 Hz. Amplitude is averaged on 10-second epochs. And then trend graphs obtained is displayed in a time of 6 cm per hour with a semi-logarithmic scale along the axis. From 0 to 5 microvolts it's linear scale here, and from 5 up to 100 microvolts it is logarithmic scale. This type of scale helps us to see both low amplitude and high amplitude EEG traces on the one trend. Due to fixed time scale 6 cm per hour, the so-called AEG patterns are clearly recognizable on the trends of the EEG, by which it is easy to access the state of the patient central nervous system. This trend is now widely used in intensive care units, both in neonatology and adults. On this slide we can see how EEG trend is calculated. Here we can see native EEG trace with low amplitude areas and high amplitude areas, and all these EEG epoch will be shown in EEG trend as only one line from minimum up to maximum amplitude in this area. On this slide we can see several different patterns of EEG trend. Now there are a lot of EEG atlases published in which all possible patterns of this trend are considered. For example, here we can see several EEG patterns. Normal EEG with continuous normal voltage pattern here. In this pattern, low amplitude is higher than 5 microvolts and the maximum amplitude is lower than 15 microvolts. Discontinuous normal voltage pattern where minimum frequency is lower than 5 microvolts and maximum frequency is higher than 10 microvolts. Continuous low voltage pattern. You can see that the minimum and maximum amplitude in this case is located in area of 5 microvolts. Burst-Suppression pattern, where we can see also dominating low amplitude on whole record, but sometimes we can see high amplitude bursts. Inactive or flat line pattern shows very low EEG activity with whole amplitude under 5 microvolts. And here we also have few examples of epileptiform activity on this trend. It is also very clearly to see where is seizures or sharp waves or high amplitude EEG areas located. Our next trend is Anesthesia Death Index, so-called NINDEX. When the neurospectrum.net program works together with the NINDEX program, a trend of the anesthesia death index can be calculated over the only one EEG channel, which reflect the patient's level of consciousness over the time. Next trend is also sometimes used for anesthesia death monitoring. It is so-called spectral entropy trend. It is calculated as a first derivative of the total power spectrum trend over the time. Our next trends are burst suppression trends. This trend shows the burst and suppression episodes which were selected during the examination, such as bursts per minute, bursts per hour, and suppression to burst ratio. These trends are often used in neonatology to assess the burst suppression EEG pattern. Our next trend is impedance. This trend reflects changes in the electrode impedance for all electrodes during the whole exam and allows timely correction of the electrode overlay. Together with the other trends, it helps to understand in which parts of the recording quality couldn't be best and artifacts are possible because of not good impedance of the electrodes. With green color, we can see good impedance under 25 kilo-ohm. With blue color, we can see not very good impedance between 25 and 40 kilo-ohm. And with red color, we can see areas where the impedance of this electrode was not very good, above 40 kilo-ohm. Our next trend is used only when biofeedback trainings are recorded. This trend shows the successfulness of whole biofeedback training during the time. In information panel, we can see current successfulness of our biofeedback training. Now let's have a look on polysomnographic trends. On this slide you can see whole list of all PSG trends available in neuronspectrum.net software. Let's look on some of them. Here on the top we can see hypnogram window, then we can see SpO2 trend, respiratory rate trend, thorax and abdominal efforts, heart rate trend, and RR intervals trend. Comparing all these trends, we can make conclusion about different recording parameters of our patients. For example, SpO2 level and heart rate or breath rate, and so on. So, to conclude, we can say that using such a powerful analysis tool as the trends, we can quickly analyze large amounts of data without the need for a long reviewing of native EEG traces. This tool saves examination analysis time. By comparing different trends on the computer screen, you can detect patterns and influences of parameters to each other. In addition, with the help of trends, it's easy to track the dynamic of the patient's condition. Thank you for your attention.